Good day, grade 12s. Let's summarize the work energy theorem question, which is question 5 in your paper 1 exam paper. Let's start with definitions. There's a couple of definitions. If say I might have forgotten something, please add it in your notes as you study and as you prepare for paper 1. You need to remember the definition for energy, which I believe you've done in grade 10. That the ability to do work. It's ability to do work. Just remember that in case they ask you. But I doubt they would ask it. The focus might be on the second definition, which is work energy theorem. This is actually a formula that says net work done on an object equals to the change in kinetic energy. So whenever you have to define this one, please go to the formula sheet and interpret this formula as it is. The net work done on an object equals the change in kinetic energy of the object. And that's the definition number 2. This one, it probably might come. It's definitely, it might come, this one. It's the popular one in this question. The other definition is conservative force. Conservative force and non-conservative force. Conservative force is here we talk about weight. In grade 12, we'll be talking about weight, but just so you know, this might be another form of conservative force that you might think about, electrostatic force, as well as the magnetic force. These 3 non-contact forces are conservative forces. The work done by these forces does not depend on the path taken. So remember that one as well. Non-conservative force, this will include all the contact forces, starting with your tension, frictional force, both kinetic and static, applied force, and any other force that is a contact force, normal force and other forces. But normal force, the work done by normal force is 0. Applied force, yeah, and any other force that you might think it's a contact force. These forces, work done by these forces on object changes the depends on the path taken. So we refer to them as non-conservative force. Please remember them when you prepare for a final exam. And the last definition will be the conservation of mechanical energy. Actually, I think this was supposed to be somewhere here, but it's fine. Just remember it. Conservation of mechanical energy. Total mechanical energy of an isolated system remains constant. Remember this one. Every definition that says conservation of something, it must be total of that thing in an isolated system remains constant. So conservation of mechanical energy, so total mechanical energy of an isolated system remains constant. And this is a formula that we are going to deal with in the next section. The other one that I might have forgotten is power. Please add it to your notes. Power. Power. The definition for power. The rate at which work is done. Also, this is a formula. It's a formula that says W divided by change in time. The rate at which work is done. So remember that one. Add it as definition number 6. Let's quickly now move to energy principles. You'd notice that sometimes some of the questions, especially the section where there's no frictional force, it's easy to apply equations of motions to solve, find maybe final velocity or initial velocity, whichever case it may be. But the examiner would always say use energy principles. So you'll not be allowed to use any other thing which is not an energy principle. The energy principle we only have 3. In grade 12, actually for now we'll only focus on these 3 energy principles. The first one is the conservation of mechanical energy. It's definition 5. We are not given this formula in the formula sheet, but you have to remember it. The total mechanical energy before will be equals to the total mechanical energy after. So this is the potential energy plus the kinetic energy of an object before equals to the potential energy and the kinetic energy of that object after. So please remember it, know how to use it. Also, this formula is only applicable when there is no frictional force. So note this very well. No non-conservative forces. If the only forces acting on the object is conservative forces, you can apply this formula. But if there's friction, applied force, or tension, you cannot apply this formula. So no friction, tension, or applied force. It works very well. Also, you don't need the mass. If you note very well, we only have one object, and the mass of an object will cancel out. If they don't give you the mass, fine. The mass will cancel out. You don't need the mass. If the mass cancels out, it generally becomes GHI plus 1 over 2 V initial squared equals to GH final plus 1 over 2 V final squared. So if they did not give you the mass, you can start it off like this so that you get a mark. You'll give a mark if you write the correct formula. Then when in your substitution, substitute all the values given to you. You can eliminate the mass, you can do away with the mass. Even if they give you the mass and you don't substitute it, it's fine. You still get a correct answer. This one only applies when there's no friction, no applied force, and no tension. Remember that all the time. The last two principles, energy principles, they can be used interchangeably. There's no restrictions to these two. They apply anyway. The net work done, this will be work done by force number 1 plus work done by force number 2 plus work done by force number 3 plus number 4 and so on, equals to 1 over 2 mass V final squared, it's change in kinetic energy, minus 1 over 2 mass V initial squared. If there are 10 forces doing work on an object, you add all the individual forces equals to change in kinetic energy, final velocity minus initial velocity. This one, the work done by non-conservative force, NC stands for non-conservative forces. So here you will not substitute weight. Only work done by tension, work done by applied force, work done by friction, if any of those is there. If one of them is not there, you don't put it in, you ignore it. So this will be done. Most of the time it's usually friction, but let's not take it like that, because sometimes an applied force might be given. So just think that remember, this is work done by non-conservative force equals to the change in kinetic in potential energy. So this is mgh final minus mgh initial. If the surface is flat, this part goes away because the height will be the same and this value will be the same. It subtracts the values, the two subtract each other. Plus 1 over 2 mv final squared minus 1 over 2 mv initial squared. It's going to be given like this in the formula sheet. So please take it slowly and go through each and every part in slowly, so that you get all the marks. This is the easiest question to score, but I've noticed that a lot of learners lose marks here because they get confused when it comes to issues of angles. How do you know that an angle is 180, it's 0 or 90? But we'll deal with that as we go through the questions. We solve the questions. I think this should give you the summary of the whole chapter. It's not a lot to remember in this chapter. There's one more formula that you can think of. It's not an energy principle though. The formula for power, which given here. It's work divided by change in time. Yeah, this is all grade 12 that you should expect, that I actually thought about as I'm preparing these notes for you. So prepare this stuff. Let's look at now one of the past papers, one of the questions, and see how you respond to this question in a test. Taking this from 2015 supplementary examination, February-March supplementary examination paper. As per the other videos where we drew free body diagrams, please know how to draw free body diagrams for question 2 and question 5. You cannot lose marks on free body diagrams. Those are free marks. You'll be expected to draw free body diagrams. For instance, I have a couple of papers in this one. This is 2019 June exam. Question 5.3 is 4 marks, free body diagram. So you can't lose those marks. In another paper, 2016, also June paper, for this one, there's no free body diagram marks, okay? But let's check another one. 2016 February, March, you are expected again to draw free body diagram for 4 marks. So please practice your free body diagrams very well and get into a test prepared. You will draw a free body diagram either on question 2 or 5, or in both the question. Question 2, remember, is Newton's laws. But let's go to this one. Let's try to answer this question. A 5 kilogram block is released from rest. This thing from rest means that the initial velocity of this thing is 0. So we start there from rest at a height of 5. So this is initial height. Initial height is 5. And slides down a frictionless inclined to point P, as shown in the diagram below. It then moves along a frictionless horizontal portion, PQ. So between the starting point up until point Q, there's no friction. P and Q is a straight line, no friction, but this is an incline, and also there's no friction. So let's continue reading. It comes to stop at point R. So the V at point R will be 0 because it comes to stop, which is about 3 meters, and the height now will be 3. And this will be the final position where it stops. The frictional force, which is a non-conservative force between the surface and the block, is 18 newtons. So let's write this down. Keep it. Frictional force is 18 newton. So we pretty much have everything that we need to go about getting this 15 marks. The paper was 15 marks in 2015. Using energy principles only. Please keep this in mind. When they say use energy principle only, you'll only use those 3 that I've shown you before. Is energy principle number 1, which is applicable when there's no frictional force, applied force or tension. Energy principle number 2, work energy theorem, and energy principle number 3. These are the energy principles. You will not be allowed to use any other thing. So let's go through the energy this question. To calculate the speed of the block at point P. So we know the speed at the initial point is 0. The speed at point P is not known. So let's refer to that as V final, and V initial will be here, 0. V final is not known. What else do you know? We know the mass of an object, even though you don't need it much. But let's go about solving this one. So first thing you do is, if this portion has no friction and you have to use energy principle, the energy principle that will be most applicable is this one, because no friction. So let's write it down then. 1 mgh initial plus 1 over 2 mv initial squared equals to mgh final plus 1 over 2 mv final squared. Let's substitute everything that we have. For initial part, we substitute all these values here, and for final part, we'll substitute this way. So this is mainly top, this will be top, this is bottom, top and bottom. The mass at top was 5. The gravitational acceleration is always 9.8 in high school, and height is 5 plus 1 over 2. The mass is still the mass of the block is still 5 kilograms. The initial velocity at initial velocity where the block starts, it's 0, and actually this makes this whole part 0. It disappears. 5 9.8. The final height at point P, this thing is on level ground, on ground level, so this is 0. It also makes this whole part disappear. The potential energy at point P is 0. The kinetic energy at initial point is 0. Plus 1 over 2, the mass is 5, and then final velocity is the one that you're looking for, or the velocity at P. Let's just call it velocity at P. This part disappears, and then you take out your calculator and solve. So this will be this. Let's quickly calculate here. It's going to be 5 times 9.8 times 5 again. This will be multiplied by 2 again times 2, and everything divided by 5. Divide by 5, and the square root of the answer. You get velocity at P is 9.8995 meters per second. I'd advise you to since this we are still going to use these numbers in other questions. It's fine even if you leave it like this. The instructions on the question paper says round off your answers to a minimum of 2. So if you write 3 numbers after the comma or 4 numbers, it's fine. There's no punishment for that. This will give you 4 marks. The formula is 1 mark. The left-hand side substitution is 1 mark. The right-hand side substitution is 1 mark. And the answer is 1 mark. And since they say they want the speed, it's not velocity, it's fine. You don't have to write the direction. Remember, speed is a scalar quantity, not direction. 5.2, explain why the kinetic energy at point P is the same as that at point Q. Now remember they said point P and Q is frictionless here. It then moves along a frictionless horizontal portion PQ. So since there's no friction, it means whatever speed is given here will be the same speed here. And kinetic energy, remember, is half mv squared. So the kinetic energy here and here will be the same because the speed is the same. So we write 5.2. Velocity is the same. Velocity at P equals to the velocity at Q because there's no friction. Point 5.3. 5.3. Explain the term non-consecutive force. Remember, it came, these definitions, you have to remember them before you get to the test. They want this one. We say that the non-conservative force is the force for which work done by an object, the force for which work done in moving an object between 2 points depends on the path taken. So remember that all the time, so that you get 2 marks for the definition. All the definitions are 2 marks. You cannot lose marks on definitions, please. 5.4 for 7 marks. If you see a question like this, 7 marks, and it scares you, please write something. Don't leave it blank. Write something. At least you'll get a few marks here and there. You shouldn't get 0. Maybe get 3 out of 7 or 5 out of 7 in that question. So calculate the angle. Calculate the angle theta of the slope QR. Remember, you're not given this the distance between Q and R. And you're also not given the, so let's say this is delta X and this will be delta Y. Delta X and delta Y. This is the vertical height. This is the distance over the incline. So energy principles are the ones that will help you, and mostly the work energy theorem or the work done by non-consecutive force. Any one of them, any that you choose, it will work for you. Let's get more paper. So 5.4, how do you solve 5.4? Excuse me. Because point Q, the distance QR is a rough surface, there is friction. It's advisable to use this one or the work done by, or the other energy principle, the last one. It will work quite well. This is work done by friction, friction plus work done by the weight, because all the forces that will act on an object as it moves up the incline, it's going, let's draw a Freeport diagram. It's the normal force, the weight, normal force, the weight. Since it's moving that way, frictional force will be in the opposite direction, frictional force. And there's no any other force except these 3. No applied force, the object is moving on its own up the incline. So the only forces that are doing work on the object is the friction and the weight. Remember, the normal is perpendicular, it's always perpendicular to the displacement, so it does 0 work. So it's equals to change in kinetic energy of the object. So this will be frictional force multiplied by the displacement, which is the frictional force is X on an object along the x-axis, and the cosine of the angle between the 2. So let's say that's cosine alpha, cos alpha, plus weight of the object, which is mg, this is the weight, multiplied by the vertical height, because the weight is downwards, acting downwards, and the object is moving up. So cosine of beta. The 2 angles are not the same, so let's use different notation, equals to 1 over 2 mv final squared minus 1 over 2 mv initial squared. So now let's substitute everything that we have in this formula. We have the friction is given to be 18. If the friction is given to be 18, so 18 displacement along the x, up the incline is not known, so it's fine. Let's just leave it as change in x. And the angle between the frictional force and the displacement. Please keep this in mind. Always the frictional force, the angle between frictional force and the displacement is going to be 180 because the frictional force is always opposite the direction of motion. So an object is going up, the frictional force is facing down. Object is going up, change in x is facing up. The object starts at point Q, it stops at point R. So change in x is facing in the direction of R. So the angle is 180 because the force is facing down, the displacement up, plus weight is 5, 9.8, and this is just the weight. The vertical height is given to be 3, and the cosine of these two. Now let's think about it. The object is going up along the y-axis. It starts from point Q to point R, so it's going up. This will be changing y. But the force, the weight here it is facing down. So it is the similar case now. The two are facing oppositely directed. So it will be cosine of 180 degrees equals to 1 over 2, 5. The final velocity of an object at point R is 0. Minus 1 over 2. The initial velocity at point Q is the same as the velocity at point P. So this will be the value that we've calculated in the other part, which is 9.8995. 9.8995 all squared. And you work out the answer to get the displacement. Let's get the displacement C. So this one is 0. It disappears. It will be this negative value minus this part, which is going to be negative on the other side. So negative 1 over 2 negative negative 1 over 2 multiplied by 5 multiplied by the previous answer. Oh, let me see, the previous answer is still there. Yes, still there. Multiplied by 5 multiplied by answer squared, and this minus this value, this whole number, 5 times 9.8 times 3 times the cosine of 180 equals to, then these two numbers, they give us minus 98. Then you divide by 18, divide by 18, negative 18, because the cosine of 180 is negative 1. You get the distance to be 5.44. 5.44 meters. But remember, the question asked for the angle, not the distance. Now, how do you use the distance and the angle? You have the sine of theta. You use trigonometric function. Sine of theta equals to the opposite over adjacent, and the opposite is change in y. Divide the opposite over hypotenuse. Excuse me. It's change in y over change in x. X along the incline. It's change in y over change in x, like this. Sine of theta is equals to change in y over change in x. And this is sine of theta equals to 3 divided by 5.44. And therefore theta becomes the arc sine of 3 over 5.44. Get the answer. So it's shift sine. How do you press arc sine on the calculator? It's shift sine, then you put in the fraction 3 divided by 5.44, and the angle becomes 33.44. 33.44 degrees. And this is for 7 marks. Let's see how it's going to be marked. 1 mark for the formula. If you write the correct formula, you'll be given a mark. If you write the formula and you use it. If you write the formula only and not use it, no mark. You should write the formula and use it. I believe the left-hand side will be given a mark. The right-hand side will be given a mark also. You get an answer. This answer, you're going to use it in the next step. Won't be marked. This substitution and answer, yes. I then to 1, 2, 3, 4, 5, 6. No, I think this will be given a separate mark from this one, from this part. So that that in all is 7 marks. This is one way of doing it, or else you can use the work energy theorem. I mean the work done by non-conservative force, which is pretty much going to be the same. This part will be the same. So let's use that method and see. Work done by non-conservative force equals to change in potential energy plus change in kinetic energy. The only conservative force, the forces acting on an object, remember, is friction and weight. And the only force that is non-conservative force here between the two is friction. So this will be the work done by friction equals to, now notice now the weight disappears because you cannot substitute the weight on the left hand side. Change in potential energy plus change in kinetic energy. So this becomes frictional force, change in x. The frictional force acts along the incline, and the cosine of alpha equals change. This is mg final h minus mg initial h plus 1 over 2 mv final minus 1 over 2 mv initial squared. This part in the other formula would be that part. This whole part will represent the change in, I mean, the work done by the weight. But let's just substitute and see. It's 18. It's not known. Cosine of 180 as before. Frictional force, the work done by frictional force is 180. Cosine, I mean, the work done by frictional force is negative. It's 5. 9.8. The final height, this is going to be 3. The initial height, it's 0 because that's on the flat surface. The height is somewhere here. The height somewhere, this height at point Q is 0. So it's going to be 5, 9.8, 0. Plus 1 over 2, 5. The final velocity is 0 because the object stops at point R. Then we have minus 1 over 2, 5. Initial velocity will be the value we calculated in the previous question. And this is still the value again, 9.8995 squared. And then you solve this equation, you substitute all these numbers in the calculator correctly, you'll still get 5.44 meters. And the other parts will continue as shown here. The other part here until you get theta to be 33.44 degrees. And this is how you solve this question. The paper 2015 February March. Go through the solutions, try to understand. If you don't understand something, please comment, ask the questions below, and I'll see what you can do. Also, the other thing, I think I'll add more of these questions in the video. This is one of them. Yes, finished. Thank you.